calculate the values of k so that h of x is equal to minus 2x plus k will not intersect the graph of g. So we are drawing some arbitrary function, minus 2x, an arbitrary straight line like that, and we want to know how high should we lift this function up, or how low should it be such that it is no longer intersecting with the graph of g, which is our the graph of g is our hyperbola. So in order to figure this out, we need to first equate the two functions and find out where they meet. So we have minus 2x plus k is equal to 8 over x, since we decided or calculated that d had a value of 8. Then we want to know at what x values will these points meet. If we multiply through by x, we find that we get minus 2x squared plus kx minus 8 is equal to 0. And then instead of solving it the normal way, we can solve it by using the discriminant. Now remember, the discriminant tells us the nature of the roots of an equation. So by equating these two functions and creating this new equation and finding its roots, we can find the values that it will intersect this one with. So we have that we want our discriminant, which is b squared minus 4ac, b being k, a being minus 2, and c being minus 8. We can substitute these values to get k squared minus 4a, which is minus 2, ac, which is minus 8, like that. All of this gives us k squared minus 64. But what good does this information give us? Remember, the discriminant tells us the nature of the roots. We want it to be such that this function has no roots, meaning we want it to be such that it is not intersecting with this one or intersecting with this one. So we expect the value of k to be in between two values. And since we have displayed the intersection of these two functions as its own function, we can say we want this function to have no roots. Remember, when a function has no roots, that means it is less than 0. So we look for values that satisfy this information, and we know from this we're gonna have k minus 8 and another k minus 8. Or actually k minus 8 and k plus 8, since it's difference of two squares. And then we have our little Cartesian plane for our critical values. Our critical values will obviously be 8 and minus 8. Therefore, we put minus 8 there and 8 over there, and then we just draw our parabolic function. And remember, we're looking for the region where it's less than 0, because the discriminant being less than 0 describes the region of no real roots. So no intersections happening in this case, and that happens in this region. So we basically want k to be greater than minus 8 but less than minus 8. That means it must be bouncing within this region over here. Another way you could have solved this is by equating the two functions together, but first calculating their derivatives, such that you're able to equate or find the points where their gradients are equal, and then finding the y-intercept of the function at that point, which would also allow you to find the same region. But overall, this is quite a difficult question, but well worth the marks.